you answers in just a second. Let me give you the definitions of the specific definition for domain and range. I know you've been doing domain and range forever, feels like, so, but it's probably good to have an actual definition. We talked about this some last year, because when you first start learning about domain and range, usually what you're told about domain is that it's X. But it's not just any X. It's the specific X that pertains to the function that you're talking about, or to the relation that you're talking about. Right now I'm saying function because most of what we're dealing with are functions, not just relations. But they're very specific X's, not just any old X. And it's the same thing with range. They are the specific Y values. So on problems 1 through 6, they gave me some functions. I think they're all functions. Yeah, they're all functions. So they gave me some functions and then asked me domain and range. So I'll put in the answers, and if you have any questions about them, then I'll answer them. So this is parentheses -4 to infinity because it's an open dot and an arrow. And -infinity to... Also parentheses because of the open dot. Alright, this one's domain has to have 2 separate pieces because of that open hole, because the graph actually stops right there. So, -infinity to 1 in union with 1 to infinity. The range, however, never stops. Okay, now that one can be a little confusing because of the open dot. But remember, range is just, does a Y value exist right there? And even though no Y value exists right here at this hole, there is a Y value of 1 right here. So it does go all the way from -infinity to positive infinity. Does that make sense? Sometimes those are a little tricky. Kind of hard to explain sometimes. Alright, this one goes domain -infinity to positive infinity. For the same reason that the last one happened like that. Yes, it's multiple pieces, but you're just checking to see, are there X values all the way through? And even though there's no X value here at 1, there is an X value here at 1. And then it starts right here after 1 and continues on. So it's -infinity to positive infinity. And range is -3 not included because it's an open dot to infinity because the arrowheads. That's going to go on forever. Alright, this domain, this one does have open holes here. So there is no value at -1 because there's not a solid place at 1 at all. So it's going to be 2 separate pieces, -infinity to -1 and -1 to 5. Parentheses because of the open dots. And this one goes -infinity to, I'm going to estimate 3.5, and that's an open dot. So far, is everybody okay? Any questions so far? Let's see. This one goes -5 to infinity. Our first bracket. We've got a bracket on -3 because it does actually touch -3 right here. And then because that arrowhead, it gets onto infinity. Okay, let's see. This is going to go -infinity to 2, where the asymptote is. And then 2 to 4. And then 4 to infinity. and then it's going to go negative infinity to infinity. That one's kind of messy and a little bit difficult to read, but we start here going negative infinity, and here we have a solid dot right here on negative 1, so even though this is an open dot, it's okay because that's solid. Starts here again right after it, so we've not had a break in x values until it gets to the asymptote. Then you got to start over. Then this is a break because there's an open dot and there's nowhere that it's filled in, and then it starts again. And then as far as range goes, you've got 2 arrowheads pointing down, which means it's going to go down forever. And it goes up to here with an open dot, but that's okay because there's a line here. And it keeps going up to here where there's an open dot, but that's okay because there's a point here. And then that goes up forever. So they're kind of hard to read sometimes when they're that messy. Is everybody okay? Yeah? Okay. All right, so then we're going to determine domain analytically. So that means we got to think about it. So first thing is, if f of x equals c. Now remember, what does f of x stand for? Y. So if y equals, and what does c typically stand for?
A y value.
A y value, constant. A constant. Or usually your y-intercept, right? It's at the end, ax plus bx equals ax squared plus bx equals c. It's your constant or your y value. So it's just some number. So I'm going to put y equals, and I'm going to put a number sign. Hashtag. But it's really a number sign. Just want y'all to know that. It was a number sign long before it was ever a hashtag. Even before that. It's a pound sign is what they're called. In case you didn't know. Okay, so it says sketch a general graph. It really doesn't matter what your graph looks like. But here's my coordinate grid. This could be anything. It could be a positive or a negative number. What is it going to look like, though?
A slope is a straight line.
Straight line. Straight horizontal line, because it would have a slope of 0. So it would be straight line like this. Bless you. So what is the domain of that? Exactly. Okay, well, a linear function. So it just says sketch a general graph. It really doesn't matter what graph you pick. You could choose the linear parent function if you want to. I'm not, and the reason I'm not is just because they put a plus b, and the linear parent function doesn't have a plus b on the end, so, but it doesn't matter, it's the same difference. So here's my linear function. What would the domain of that linear function be? Negative infinity to positive infinity. If it's a linear function, that won't change. It will always have a domain of negative infinity to positive infinity. The only thing that might change it is if you had a problem situation. They actually gave you a word problem, and it was a linear word problem, but they told you specifically that you were dealing with tacos. You can't have negative tacos, so you have to start at 0. But other than that, it'll always go negative infinity to positive infinity. Okay, sketch again general graph. What does this one look like? V. It's a V. And again, it has a plus C on it, so I'm not going to put it at the origin. You can. It's not a big deal to do. But since it has that plus C, that means it's been shifted. Oh, it has a minus B also, so I'll do that. What is the domain? Negative infinity to positive infinity. And the last one that they give us is a quadratic. What does it look like? It's a parabola, a U. It's got a plus C on it, it's been moved, and what's the domain and range on that one?
Negative.
Well, do you think they grouped all of those together for a reason? They have the same domain. So now we get the next set. Do you think the next set all has negative infinity, positive infinity? No. So they gave you those first 4 because I hate to say they're the easy ones, but the domain of those 4 doesn't change. And as a matter of fact, yesterday in Algebra 2, that's what we were doing, is we were doing the domain and range of the parent functions. We were matching up cards. I don't know if y'all remember that activity, but we were matching up cards, and I told them all, start with the linear parent function and the quadratic, because those are the two you know, because that's what you do in ninth grade. And then after that, do absolute value, because it's just like quadratic. So they're the easy ones. Then we get into the more difficult ones. So let's look at, first of all, what kind of function is this?
Radical. No. It's an R one.
Rational. Because it's a ratio. The word rational comes from ratio. There's a ratio to fraction. Yes. So it's rational. That's where it comes from. So I'm going to write that up here so that I don't forget. Rational function. That's what this is. Okay. So let's see. It says, given below are the graphs of three different functions. The best way analytically refer to them as you complete the table below. Okay. So we're going to refer to this graph as we complete this function, as we complete this below. All right. Find the indicated function value, f of negative 2. So we're going to go up here on our graph, and I'm going to go to f of negative 2. And what do you find?
Undefined.
It is undefined. Now, I could find it by looking at the graph, but what if I didn't have the graph? What would I do with that negative 2?
Solve
Plug it in.
the equation.
Plug it in. So let's plug it in real quick and see what happens. I don't even have to think about the top, because what happens on the bottom? It goes to 0. Can you divide by 0? No. So f of negative 2 is undefined. So even if you didn't have the graph, you could have found that by trying to solve it out. All right, let's use the graph. It says f of negative 1. Let's look at the graph first, and then we'll do it analytically also. What should I get if I go to f of negative 1? Positive 2. Let's plug it in, because sometimes you're not going to have the graph. Just to practice. Oh, I did. I got 2. Y'all get 2 when we do it analytically?
Yes.
Okay, so what conclusions can you make about the domain of the function based on these two computations? If we weren't looking at the graph, we were just looking at the computations. So what does this tell me? What does this tell me about the domain? Do we know that it's an asymptote yet?
No.
So you don't have to. But what do you know?
There's
There's nothing there. So it could be an asymptote, or it could be a hole, or what we call removable discontinuity, a point discontinuity. But what we do know is that f of negative 2 is not in the domain, because they asked specifically about the domain. It can't be, because no y value exists there. So negative 2 can't be in the domain. So x equals negative 2 is not part of the domain. And we know from this calculation that x equals negative 1 is in the domain, because I got an answer. So let's go up and actually write the domain of this one. All right, so we're going to start with how far left it goes. So negative infinity to negative 2, parentheses because it's a asymptote, doesn't actually touch negative 2, in union with, starts over again right after negative 2, goes to 2, also parentheses because it's an open dot, in union with 2 to infinity. Okay, what do we call this function? That's square root or radical. You can call it either one. so let's start by looking at the graph. G of -4 should give me 3. So I'm going to try it analytically just to make sure. It does. Okay, G of 9. Now I look at my graph and I don't have a 9 up here. But what could you tell me? Even though we don't have 9, what can you tell me? It's not going to be a 9 because this graph stops right here. It goes forever the other way. So there's no 9 in this, so it should be undefined. But let's plug it in and see. So I get square root of -4, which means what kind of number is that? 2i. It would be 2i, which is imaginary, which you can't graph. So we'll still call it undefined because it doesn't mean that it doesn't exist. It just means it's not graphable. We can't graph imaginary numbers. So we'll say this is undefined. So what we know is that x equals -4 is in the domain. Where x equals 9 is not. All right. What kind of function is this one? Cube root. Alright, so the first one it asks me is h of -11. Now, I can look at the graph and see, is there going to be a value at -11? There will be, but I can't tell what it is until we plug it in. So let's go ahead and plug it in. And don't forget, it's okay if you have negatives under a radical that has an odd index. That's okay. Because -2 times -2 is +2 times another -2 does in fact give you -8. So this is okay. So I get -2. Everybody okay? Alright. Let's see. We have the same issue with h of 5. I can look at my graph and see that a number is going to exist there. But I'm going to have to plug it in to find out what number does exist. Alright, so in this case, x equals -11 and 2 are both in the domain. Oh, I'm sorry, I said 2. 5. 2 is also, but that's not what we checked. So let's go up and write the domain. Oh, they should have put this one on the other page. I didn't write it on the square root. We'll do it to -infinity to +infinity. Let's go back and do the radical. Let's see. How far left? How far right? And bracket. There, very good. Bracket. So that's a solid dot there on the 5. So far, so good? Everybody feel good about this? This is easy, right? Okay, so based on what we did before, based on this information that we did on the rational function, what conclusion can you make about how to determine domain? Or can you make any conclusions about how to determine domain? Did y'all notice anything? What caused an issue in our domain? The asymptote is definitely what causes the issue, but when we were calculating, what if we didn't have the graph and we didn't know what's an asymptote? How do you know from calculating? What happened?
If it's undefined.
If it's undefined, what makes it undefined?
The numbers in the function.
You can't get a 0 in the denominator. If the denominator goes to 0, that's a problem, because that's what makes it undefined. So, that's what we're going to put up here. The denominator of a rational function cannot equal 0, ever. So if we can find what causes the bottom to equal 0, you can find domain without looking at it, without a graph. Okay, so the first example, they were so nice to us on the first example. It is already factored. So first thing you want to look for, don't forget, we got to think back to holes. And those of you who just had Algebra 2, we did a worksheet called Remove the Bulb. If you remember, if it's the same on bottom as it is on top, you have a factor that's the same on bottom that is on top, that's a hole, not an asymptote. But in this first one, I don't have that. None of my factors are the same. So I have 2 factors on bottom, and neither one of them could go to 0. Because it's multiplication, and if you multiply anything by 0, it's 0. So if either of them went to 0, it would cause the problem. So you take both pieces and set them equal to 0. Because that's what we need to know. What would cause either of those factors to go to 0? Well, if I just solve this, I get x equals 3 and x equals 1. Now, just in case somebody's not clear, let me make sure you understand what happens. See, if 3 was part of my domain, and I took 3 and I put it right here, 3 minus 3 is 0, right? It doesn't matter that 3 minus 1 is 2, because 0 times 2 is still 0. So it would cause the whole thing on bottom to go to 0, and that can't happen. Same thing if x is 1. I put it right here. 1 minus 3 is negative 2, so I'm good so far. But 1 minus 1 is 0. And negative 2 times 0 is 0, and that can't happen. So neither of those numbers can be part of my domain. Since I know that I don't have any holes, because nothing matched on top and on bottom, these are the 2 x values it cannot be. With rational functions, it can be everything else. So I'm going to go negative infinity to 1. And this is rational, so these are asymptotes. So it's not a bracket, but it's a parentheses. In union with 1 to 3, in union with 3 to infinity. Everybody okay? All right, so on number 2, they weren't quite as nice because they didn't factor it for us. But we can factor that easy enough. How do I factor x squared minus 9? Good. X plus 3x minus 3, doesn't matter what order you put them in. Check for holes, so that would be if a factor on top matched any of the factors on bottom. No holes this time. So I'm just looking for asymptotes. So I take both pieces, set them equal to 0. No, when you get really good, you don't have to do this part. Comes out to be x equals negative 3 and x equals 3. So I've got 2 asymptotes again. So negative infinity to negative 3 in union with negative 3 to 3 in union with 3 to infinity. Make sure that you put them in smallest to greatest order. That'll happen, sometimes it'll mess you up. You always have to go smallest first, left to right. and the bottom. The top factors, x minus 2, x plus 1. The bottom, we have to do bottoms up. Did y'all get x minus 3, 2x plus 1? On the bottom? Did I go too fast? Oh, wait. That's right. Okay. I have no matching factors. So, no holes, which means these two pieces both have to be asymptotes. So x minus 3 equals 0, and 2x plus 1 equals 0. So I got x equals 3 and x equals negative 1/2. So those are my two asymptotes. Make sure you put the smallest one first. So I'm going to go to from negative infinity to negative 1/2. Negative 1/2 to 3. We'll start there tomorrow.
She like shuffle.
She's like, bye.
Yeah. A lot of fun.
Hey, Dairy Queen for lunch. We're going to Dairy Queen? Yes. With Harvey? No. With us. Them. Me, and you, and Tessa, and Daniel.
Oh, okay. Alright, so good. Alright.
Miss Lady needs you to come help her. She's having Mr. Bivens' class come over and vote, so she wants you to come help.
Right now?
Yeah, and I'm just gonna, I'll cover the end of the notes, and then that'll be it today.
Okay.
So y'all can work on that exercise.
All right. I'll do that.
Oh my gosh, that video's still going. Brittany's gonna be like, I didn't need all that passing period and